Consider an infinite chain of identical point charges Q on a line in a vacuum. The distance between each pair of consecutive charges is L. So, what is the electric field at a distance L from the chain on the same line? Look at the following illustration. We have an infinite number of charges Q, and we want to compute the total electric field at the red spot. Each charge creates its own electric field. For example, the first charge, which is at a distance L, will generate an electric field E1. The second charge, which is at a distance 2L, will generate an electric field E2. The third charge, which is at a distance 3L, will generate an electric field E3. And in general, the nth charge, which is at a distance NL, will generate an electric field En. This is a purely one-dimensional problem because all the charges are aligned and the point where we will calculate the electric field is on the same line. In this illustration, I have assumed that Q is positive, so the electric fields point outward, to the right in this case, but they could also point to the left if Q is negative. So the formula for the electric field due to a charge Q at a distance r in vacuum is the one you see here, where epsilon 0 is the electric constant and r hat is the unit vector joining the position of the charge and the point where the electric field will be calculated. We want to add the contribution of the electric fields produced by the infinite charges. To do this, we will write the general expression of the electric field generated by the nth charge, and we will perform an infinite summation. So we know that all charges have the same charge Q, that is a constant. We know that the nth charge is at a distance NL, and assuming that all charges are aligned on the x-axis and their contribution is strictly along this axis, the direction is constant and is given by the unit vector I hat. So now all we have to do is compute this summation. We take all the constants out of the summation, and the only term that depends on n will stay in the summation. The sum of the inverses of the squares of the natural numbers is a very well-known sum. We know that it evaluates to pi squared divided by 6. So finally, if we cancel out a factor pi and multiply 4 by 6, we arrive at the final result. The total electric field is pi times q divided by 24 times epsilon 0 times L squared, in the direction of the line on which the charges are placed, pointing outward if the charges are positive and inward if they are negative.